Hey everyone, on this side, I hope you all are doing well. So let's see the problem of the day. So the problem here we are given is minimum cost of buying candies with discount. So you can pause the video and read the problem. So the problem basically saying is you are given an array like 1, 2, 3, 4, 5. You are given an array where each item represents a price of a candy. Okay, so you are given an array that contains candy and the value represents the price of that candy. Okay, so what you are going to do that you have to there is a special condition for every two candy you get a third candy for free. You pick a candy A and candy B. So after purchasing candy E and candy B, you get candy C for free only if the minimum of A comma B is greater than or equal to candy C. Okay. So basically C should less than equal to A and C should less than equal to B. Okay. So what we have to do, we have to minimize the cost of buying all candy. Okay. So for example, you purchased 3 and 4. So you get 2 for free because 2 is less than 3 or 4. Either 2 or either one. Okay. And if you purchased 4 or 5, you can get 3 for free. Okay. So if for example you purchased 4 and 5, you got 3 for free. You purchased 2 and 1 and there is nothing left to get for free. Okay. So what will the total cost? You purchased 4 plus 5. That's gonna become 9. 4 plus 5, 9. 2 plus 1, 3. So the total cost gonna become 9 plus 3, 10, 11, 12. Okay. So you spent 12 and you got 5 plus 9 plus 2 plus 1 plus 3. That is total 15. Okay. So you got a value of 15 at spending just 12. The approach we are going here to use is we have to get the free candy of maximum possible price. Okay. For example, we have candy list like 10, 15, 16, 18, 20, 30. So what we can do, we are trying to get the, I mean, costliest candy for free. So can we get 30 for free? No. Can we get 20 for free? No. Can we get 18 for free? Yes, if we buy 30 plus 20, we can get 18 for free. If we buy 16 plus 15, we can get 10 for free. So basically what we have to do is we have to first sort the array. Okay. So we are given, let's consider after sorting array, let's consider a sorted array like, so what we have to do, we have to iterate from back and purchase two candy and we get the third candy for free. Like we purchased these two and get this one for free. We purchased these two and get this one for free. Okay. So what basically we are going to do is while index is greater than 0, we have to do is let's let's get total cost equal to 0. So if index is greater than 0, what we have to do? Let's consider indexes here. So cost gonna become cost of this index, candy at index, cost of this index plus candy of index minus 1. And after purchasing this, we gonna get this for free. So we have to move this directly to here because we purchased all three. We have to pay for 32 and 45 and we're gonna get 26 as free. So what we gonna do is index equal to index minus 3 because we get the three candies. Okay. And if you notice, I didn't write greater, equal to, because if I gonna write here equal to, it's gonna exceed the limit. 0 minus 1 gonna become minus 1 and that's an invalid index. So if we have something like 1, 2, 3, 4, index is at 4, we're gonna purchase 3 and 4 and gonna get 2 for free. And now index become minus 3, so index gonna become at 0. So we're gonna handle 0 separately. So if not index, index equal to 0, we're gonna do and cost equal to cost plus candy of 0. Okay, so that's how we gonna do that. So let's consider another example. First, 6, 2, 1, 5, 3, 9, 2, 2, and 8. Okay, so what the first thing we have to do is we have to sort it first. So we're gonna sort it like 1, 2, 2, 2, 3, 5, 6, 8, 9, 8, 9. Okay. So after sorting, what we have to do? First stand at index I. index, last index. Gonna purchase 8 and 9, so cost gonna become 8 plus 9, and move this to, gonna do minus 3. Now purchase 5 and 3, 5 plus 3. Here we get 6 for free after purchasing 9 and 8, and after purchasing 5 and 3, we're gonna get 2 for free and do minus 3, and then purchase 2 and 1, 2 and 2. After purchasing 2 and 2, we're gonna get 1 for free. Okay, so the total cost gonna become 8 to 10, 5, 3, 8 to 29. So at cost of 29, we're gonna purchase all candy, and total candy is worth 30 and 38. So at cost of 39, we're gonna get 38 candies. Okay. So let's code this. And that's equal to candy dot style minus 1. We're gonna do, I mean, we're gonna do cost equal to, we're gonna do cost equal to cost plus candy at index and candy at index minus 1. And after purchasing, what we're gonna do is do index to minus 3. And if we left with one index, I mean that's 0. If we left with 0, we're gonna do cost. I mean, we're gonna add the cost of first candy to one candy of 0. Okay, and simply return the cost. So let's see. Okay, we forgot to sort the array. So we have to first sort the candy. We got to begin candy dot end. After sorting, let's submit the code and see if it's working or not. Okay, we got perfectly fine code, and let's analyze the time complexity and space complexity of our code. So the time complexity of this for loop is big O of n by 3, and that is big O of n, and time complexity for time taken to sort the L, time complexity for sorting equal to n log m. So overall total time complexity gonna become big O of n log n plus big O of n by 3. So we're gonna eliminate the, I mean, lower factor. So the time complexity gonna become big O of n log n. Space complexity gonna remain constant because we are not using any extra space. So I mean, that's the question. Oh, that's it for today. I hope you like this video. So please make sure to subscribe to Tensor and feel free to ask any doubts in comment. And till then, keep smiling, keep coding.